Hi guys, welcome to part 2 of this repair video. So this is the Lenovo laptop which was subject of part 1, and the basic problem is that the white light, the power on light, is flashing on and off slowly, and the fan is either spinning or not spinning slowly. So that's what it's basically doing. Now the problem I could find, and it was on the video, is that there was effectively this power rail wasn't powering up. So on here I was seeing occasionally 0.3 of a volt or 0.35 of a volt and then 0.350, and this measures 3 ohms roughly to ground. These ones were powering up. This is the V core, 2 phases, reads about 2 ohms to ground. RAM supply was powering up 1.2 volts, and all the other ones were on steady basically. So I asked for some interesting suggestions and made it interactive. And the suggestions basically fell into 2 main camps. One was to lift this inductor from the board and measure the voltage on the MOSFETs to see if I could figure out what voltage supply should be, and if this voltage supply comes up when it's not connected to the load. So by removing the inductor, we're disconnecting the load. So that was one main camp who thought something like that. There was 1 or 2 suggestions. For instance, there might be a short circuit in the USB connectors. I've checked them all, they look okay. I haven't measured for shorts, but there's certainly no visible damage there. And the other main camp, if you like, were the ones who thought it was a corrupted BIOS. So I had a look around, first of all, to try and figure out what this voltage should be. And I managed to find a schematic for this. I'm going to put the schematic in the Learning Electronics Repair Discord, unless somebody else has already put it on now. I'll have a look. If not, I'll load the schematics for this. And I'll just show you on the schematic now what I found out about this supply. Now, the way I did it, the part number for this inductor is PL5901. And that's what I looked for in the schematic. So let's have a look to see what I found. This then is the schematic, and as usual with the schematic, there's lots and lots of it. So the easiest way to find what we're looking for is to search for the actual component number. So to do that in my PDF browser, it's just Control F, and I can search in here. So for PL5901, okay, hit the up or down arrow. In fact, it's found it already for me. It did it anyway. So if I zoom in a little bit, you can see here PL5901. These are the 2 MOSFETs, the buck converter, and it generates this voltage VCC GT. Now I wasn't sure what this voltage is. I was trying to make some sense out of this information to see what the voltage supply should be. And from the schematic I then searched for VCC GT. So that took me all around various places in the schematic where this goes to. So I can show you what the supply actually does. It goes, well, this is just capacitors. It gives us a little chart here, which effectively is the power on sequence, but it doesn't tell us what the voltage actually is. And you can see it goes to the CPU, Whiskey Lake CPU. So this is the CPU, and that's where it actually goes, okay? So I figured out where it goes, but I don't know still what the voltage is. So I then did a search in Google for VCC GT with the underscore. Didn't really find anything. Tried it without the underscore, and I found a link to this document. So this is the actual data sheet for the processor. Again, it's very, very long, but there's a few interesting parts from our point of view. So if I can just scroll through, there's a picture of it. So this is the PCH, this is the processor, okay? And if we scroll down near to the bottom, it gives us some information on the various voltages. So DC specifications for VCC PLL, that's a voltage rail. VCCST, if I keep scrolling through, VCCIO, SA, and eventually VCC DDQ. Keep going. Then we find VCC GT. So it's actually the processor graphics that this supplies, okay, which is built in the CPU. And this should give us the actual voltage. Now, all I can find is that the maximum is 1.52. Yeah. The maximum is 1.52. That's all it really tells me. So it, again, doesn't specifically tell me. But what it does tell me is this can draw up to 31 amps. So that means, just with Ohm's law, this must be a low resistance load. So it's quite possible the 3 ohms I'm seeing is actually quite normal. It's not a short or a near short, and that's not why that power supply is shutting down. So I then, given that information, I'm hoping you can see the sense in that it is a low resistance rail. I thought I'll go with the other suggestion, which it was corrupted BIOS. Now that took me to bad caps. Yeah. And there's a whole thread about this with really like many posts on it. Yeah, there's page after page of it. I think there's like 8 or 9 pages of it. And this basically describes the same problem I have. And there's lots of versions of this. So I found the version I have, which is not actually this one. It's actually this one, 15IWL. But this motherboard version has a number of different processor types. And mine is actually an i5. I couldn't find one here specifically that is. But the other thing reading through this thread is that effectively there is some information in your BIOS, some sort of DMC, digital rights or type thing that you have to effectively extract or use to make a, if you like, virgin copy of this BIOS work. So given all that information, I'm going to remove the BIOS chip from the motherboard. We'll read it. We'll post the information up here onto bad caps. I mean, this is being posted on very recently, 13th of July. There's lots and lots of people have had this sort of problem. And then let's see what we get if we get a response. If somebody's, quite possibly this guy, he's done a lot of the replies on here, will then post us back effectively a fixed BIOS file. So to do this, the first thing I need to do is actually find the BIOS chip. It could be, it's probably going to be an 8-pin IC, what's called SOIC, small outline IC. Something that looks like that. Whether that is actually the BIOS chip, I'm not sure. There may be some more on the other side. But we definitely have to take the motherboard off because we need to desolder this with hot air. And it's not the sort of thing we can do while it's all effectively put together. So let's get this motherboard out of this casing. I'll find a suitable screwdriver. Okay, I think I have one. And we'll remove the motherboard. I think there's a few screws around here that are probably holding it in. I'm not totally sure. Possibly not. They're usually marked with like little arrows by them. See, that has a little arrow by it. Yeah, there. So let's try to find the ones with the arrows by them. And also we need to just remove the various other connectors we have here as well. These things normally lift up or something similar. Sometimes they just pull out. Let's see if we can get the board loose first. There's another one here with a little arrow by it. Okay, that's two of them out. This one I'll probably need some tweezers to get it out. This will have to come off the little Wi-Fi adapter. Somebody suggested I remove this as well to see if it works without it, if there's maybe a short on this would cause this sort of problem. Okay, so we can take that out. Looks like this one goes onto the actual fan. Probably have to remove it. We'll get the various screws unfastened on the actual heatsink. Okay. Oops, just dropped it. Okay, so that's off. There's a connector. This is the one for the actual screen. Just lift that up, flick it out. And I'm just trying to figure out what's actually holding this down just by flexing it very slightly. Yeah, this one has a little arrow by it, so certainly that has to come out. And that one was already removed, a little arrow by it. Okay, so that's that one. Still something down here holding it quite tightly. This we can flick up. Yeah. Same with these ones. These I tried to remove before, though they seem to be glued down to the actual PCB. So let's just see if we can actually, yeah, peel it off a little bit. Yeah, it's out. It is glued to the PCB, but I've just unglued it basically. I just unglued it. This one's off. This one flicks up at the back, yeah. Sometimes you find them like that, they flick up at the back. Might need to use tweezers just to move this one. Again, it quite possibly, yeah, it's come out. There's still something holding this down, it's quite tight. I guess we're going to have to remove this one. And that means we'll probably have to remove the other two just to get the fan out of the way. These can be quite awkward to do. Try to get the okay, done. Yeah, probably take this off is going to be easiest. Okay, try to remember which screws went where. Although if I don't have a screw left over by the end, I think I've done something wrong, yeah. Okay, this is now fairly loose. And it may in fact just come out. Let's have a look. It might just be that this is actually sliding down here. Just seems to be something holding it. What is it? I don't see any more screws down here, but something seems to be just keeping this in place. Yeah. Oh, you see that there? That'll be it. Yeah. That'll be it. Now I'm sure this will just come out. Yeah, okay. Let's try and find our BIOS chip. The BIOS chip's usually fairly easy to find. I don't see anything on this side that looks like one. And the reason I say looks like one, because they're almost always an 8-pin chip in the small outline IC, SOIC package. And the only one I see at the moment is that. So I'm suspecting this is our BIOS chip. And if I get a little bit of focus on it, we can have a look at the part number. Okay, this is the only likely candidate. I'll get a bit of light on it there, so you can see AH1935, but then this number 25B127DSIG, that is almost certainly an EEPROM. Normally they start 24, 25, 26, 27, and then a letter, and then some more numbers, letters, yeah. So we know this is the EEPROM. It's very close to this. which is the DIMM slot, a bit of an awkward place. We need to use hot air to desolder this, and we need to kind of like blow it away from the DIMM holder because we don't want to melt it, yeah? Let's get back over to the desktop camera. There are some programmers, even the one I have, that do have a facility for programming chips in circuit. But in my experience, it doesn't work or doesn't work well. First of all, this will be on the 3.3 volt supply rail on the laptop. Basically, you would have to supply power to that entire rail, 3.3 volts, to be able to have any chance at all of programming the chip. And you could do that with a bench power supply, but to me it's far more hassle than it's worth and isn't necessarily that reliable even if you can do it. So the thing is to desolder this chip. And although it's close to here, it's not actually as difficult as it might look. So let me show you how I do this. And I know some of you guys have seen it before, so if you've seen it before, just skip forwards, yeah? First thing you need to do this is to use some flux. I recommend this one. If you look in the video description, you'll find links to all these things. If you buy from the links, I get a little bit of commission, but you just pay the normal price, so it doesn't cost you. If you want to help support the channel, that's a great way of doing it. And we'll put some flux onto our chip. Okay. Next thing we need is a soldering iron with a good chunky tip. This is a T12 soldering iron, KSGR. Again, it's in the links if you want to buy. And this has a BC3 tip, and this is the sort of thing you need for this, not something with a fine tip. You need to get a fair bit of heat in this to actually do it. If you use a conical type tip, something fine point, you won't do it. Let me show you how to do this with a chunky tip. So basically we're going to add some leaded solder. Some leaded solder, yeah. Not lead free stuff, it's rubbish. That's my opinion. But leaded solder, we're going to add some to all of the pins. And what I'm going to try and do is get them to bridge together, like so, yeah. Or even all four bridge together, like so. And we're going to come to the other side and a nice blob of leaded solder and do the same. So what we've now done is we've got all our pins effectively just bridged together, okay? And that'll be much easier to unsolder now using hot air, because this leaded solder will melt before any of the nearby components which are using unleaded solder do. So we'll get us on top of something so it's not on my bench, so I don't burn the anti-static mat. They ain't cheap to buy. And then let's do it. I need a pair of tweezers. Now, I'm right-handed, so I use the tweezers in my right hand. I recommend you do the same. I'm going to turn it around this way so I can grab the chip by either end and lift it off. If you want to, you can put capped-on tape around here to cover any nearby components, but if you're used to doing this, it probably isn't a problem. And we want to blow the hot air in from this direction away from this. It's probably worth putting a bit of capped-on tape on this plastic. Okay, so we'll get a little bit of this. I have my own way of doing it. Comments below. Yeah. You can chastise me for doing that, but you ain't going to stop me from doing that, yeah. But if you want to chastise me, feel free. So I'll have a bit of that there. I'm not going to bother on the other stuff. If you look, you'll see that the board in this direction is free. So I'm going to take it that way as I lift it up, not towards these components. If you put tape on here, all you'll probably do is make it harder to get heat into the board, to be honest. Hot air, mine's a quick 861DW, but use what you have. This is pretty fast. So I'll just first of all get this entire area warm but away from this plastic. The more heat I get into the board this way, the easier it's going to be to do it. Okay, that's getting a bit warm now, so I'm coming from this direction. And I should see this solder melting. You should see it as well. It's going, yeah. And there it comes off. You see that? Solder melting. Now we've got a bit of excess solder on the board. Is the best time while it's hot to remove that. So we'll take a bit of solder braid, the chunky soldering iron again, and we can just dab this on here. Okay. And that's removed the excess solder. We haven't dislodged anything. I'm sure you can see everything's still exactly where it was. And what made that easy was putting the leaded solder on it, because you reduced the melting point of this to the point where this was completely liquid before the other solder even started to melt. Okay. Let's look at our EEPROM chip. So here's a chip. It came off nice and clean. You can program this with probably a couple of different programmers. In fact, I'm sure there's several programmers you could. I use the TL866, and I will say that if you want to repair motherboards, graphics cards, and a lot of other devices, an EEPROM programmer is one of the most useful things you can buy. It makes an easy fix out of an impossible one, basically. Common ones, the TL866, 2+, which is the latest. Mine is a slightly older version of it. Or the CH341, which is quite a bit cheaper, but doesn't program such a range of chips. Okay, so we know what we're going to use, so let's get the programmer out and let's see how we're going to do it. This is the TL866. It's a USB programmer. It's very simple to use. You can buy them on their own, or you can buy them with a whole range of adapters. And sometimes there's many adapters. I'd probably buy them. I mean, I can show you what I have. I had better zoom out, hadn't I? I bought one with a number of different adapters. I didn't have them all initially. This is a 1.8 volt adapter, which I bought at a later date. This is a CH341. This is another programmer I bought at a later date. But I only bought this for doing specific things that the other one could not do. And I have a number of adapters, some of which came with it, some of which I then bought later, such as this one. So I suggest you buy one with some adapters. Still get the SOIC, or small outline IC, 8 pin, maybe 16 pin. And then add to it, so if you come across something you don't have the right adapter for, you can buy more, yeah? To program this type of chip, I used to use, if I can find it, yes, this one. So with this, you solder the EEPROM to the adapter on here, the right way round, it's marked. You program it and then you desolder it and put it back into the laptop or GPU or whatever else it came out of. And that works, and I could use that today. But since then, I bought a few of these type adapters. So this just makes it easier. It's not necessary, it's just easier to do the job. So I'll show you how this works. It's a very simple device. As you push on it, you'll see the little jaws open and close. Yeah, that's something off Alien. Yeah. So what we do is we take our IC and we put it in the adapter. This end is pin 1, so this is pin 1 effectively. So it goes in this way round, and the EEPROM will have a dot on it, so we know which end is pin 1. So we just get the EEPROM, I can see which way round it goes, and we pop it in here. Yeah, we drop it into the jaws of the Alien, yeah. Let go, and it's now nicely gripped. It's slightly out of line, but I'm sure all the contacts are making. We can just slide it this way slightly. And then wish we'd never touched it, because we should have just left it alone. Isn't that always the case? And it's there, yeah. So we now just put this into our programmer. Very simple again. Pins go to the top. Sometimes you find they don't fit and you have to move the things slightly down to get them go in. This one fits. Okay, and that's in there, ready to connect the USB and to program it. Now we need to run the MiniPro software, and we need to find our chip, which is 25B127. And in fact, the programmer doesn't know that chip. I've tried actually another software with this and it also doesn't recognise it. So sometimes you may find that you have to use a different chip type to read it. If we look, this is the actual schematic we were looking at, and if I can zoom in a little bit, this is our EEPROM. So this actually has it as a 25Q128 rather than the 127B127. So I'm guessing it's actually compatible with this. It's UC702, which matches the motherboard. That's the actual part number of the EEPROM on the motherboard on the silk screen, so I know I have the right chip. So let's try this one. And we can put the W in, or maybe without, W25Q128. Let's see if it finds this one. So again, we'll go to select and we'll go W25Q. Yeah, it's finding this by the looks of it, 128. Okay, and then it has some letters after it, JV. We don't seem to have a JV, so I'm going to try a couple things. Let's just try it without the W. Okay, that's found with some other prefixes, if you like. Put the W back in. I know it's a small outline IC, so I'm going to have to try one of these. Otherwise, I'll have to ask online, which is actually the one I need. I know it's not a 1.8 volt because it has a 3.3 volt supply. You can see it here on the schematic, so we know it's a 3.3 volt. So we'll try this one. We also know it's a small outline IC, 8 pin, so that matches. So let's try to read this and see whether we can read it. So we'll click on the R to read, and we read. Now it might well say that the ID is incorrect. Yeah, check ID error. So this was checking for the part. Now what I can do is actually tell it to skip that. So we take the tick out of check ID. Let's try to read it again and see if we can actually read this chip. It's now reading. So it appears we can read the chip on this setting. We'll know if we have anything that looks sensible when it's completed. So let's let that read the chip and then see what we get. Okay, it says it's ready, so we'll just hit cancel now. Well, let's have a look. Yeah, we're reading data from it. It's not unusual to find blocks of FF like this. What you may find is some text in it. Let's have a quick look. Let's just scroll down this and see what we've got. Often towards the end, but not always, yeah, you find some clear text, yeah. So it looks very likely, yeah, reserved end of media. We're reading this, yeah. Messages and stuff, which look like BIOS messages to me, which are in the ROM as plain text, yeah. So I suspect we've read this okay. Let's save the file. I need to put it somewhere. We better give it a name though, hadn't we, first? We'll go to original, so that's the one I've read. Okay, and we've now saved the file. So I'm now going to upload this file onto Badcap's forum, and there's a thread for this particular laptop, which I found after I did the initial checks on it, and thanks to some of the comments that you guys have put on. Let's have a look. This is badcaps.net forum. This is the BIOS request section in the laptops, tablets and mobile devices area, and it's basically started by somebody who wanted a BIOS for this, and it's gone on to like 8 pages. So you can have a look through this. I will link it in the video description. This is my post, so just briefly I'm explaining what the problem is that I've attached the EEPROM file. Then I'm explaining in detail, because this matters sometimes. Give as much information as you can. So I'm explaining what type of EEPROM is on my board. I'm explaining what I found on the schematic, and then I'm explaining the one that I used on my EEPROM programmer, and then I'm giving full details of the laptop, including the CPU type, because that will vary, the revision, all the information is there. So hopefully the guys have got what they need. Then to give back, I always try to give back. I have the schematic, maybe somebody wants it, maybe it's already on here, so I've attached the schematic if anybody wants it, and that is my EEPROM. So now we just have to wait. Let's see, it's today at 10:46 AM. Let's see how long it takes to get a reply. Okay guys, so I posted the request at 10:46 this morning, and at 11:30, 45 minutes later, I got the file. So he's actually given me the file I want. This file is for the EC. That's something else I want to play with. I have a programmer now for the EC chips, or Super IO, and that will be on a review video soon. But for now, I basically need this file. So I've downloaded the file, and we have it in the folder. This is the file he gave me. I've unzipped it, and in here we can see a bin file. So this is the bin file which this guy SMD3, thanks very much mate, has given me. We can look at the file. It's a 16 megabyte file, and if we compare that with the original version which I uploaded, it's a 16 megabyte file. So it's ready. Let's see if we can program the chip. So to do this, we need the Mini Pro software. It's still set to the same chip which I actually read from, so we can leave that the same. We need to open the file. So open, and in here is the file which he gave me. I'll just click on OK. And we can have a quick look. I imagine it probably looks much like the other one. Yeah, you can see all that text towards the bottom end of it again, yeah. Like we could see in the other one. So that's our file, and now we quite simply hit program. I'll leave the check ID switched off because I'm effectively selecting a different chip, but it seems to be compatible. Otherwise you can have that switched on, and we can hit program. And it's now programming our chip. In fact, at the moment it says it's erasing the chip, and now it is programming. This will probably take a little while, certainly longer than it took to read it, so I'll just speed up this part of the video. And you can see it's programmed successfully, so we can fit the chip back onto our motherboard, and let's see if it now works. Refitting the chip is quite simple. In fact, it's easier than it was to desolder. We're going to use the soldering iron, so we don't need hot air, so we can take this piece of Kapton tape off. Not necessary. First of all, then, we will just clean up this area of the board, get the old flux off, and then we can put a bit of fresh flux and solder it. So, little stiff paintbrush I use. This is quite coarse, a bit like a toothbrush. Came in with a pack of tools I bought for mobile phone repair, although I don't actually do mobile phone repair. But sometimes I see stuff and I just can't resist it, yeah. So I use the spudges and stuff for laptop repair, so I got some use out of it. So we can clean that area up. We can get our chip, make sure it's the right way round. So we have a little notch at one end of it, or an arrow, yeah. In this case it's actually marked with a number 1 on pin 1. So the chip actually goes like so. It'll probably be easier to do this with tweezers. I often hold it with my fingers, but it's a bit close to this, so a bit awkward to get at. So I can effectively place it on the board like so, and what I'll normally do is tag one of the pins on one side first, make sure it's straight, tag a second pin often on the other side, make sure it's flat against the board, it is, and then I can solder the remaining pins. Once again, I'll use the chunky soldering iron tip which you see me using all the time, the BC3. It's far easier. If you think you should be using a fine soldering iron tip for this, you're absolutely wrong. You can't get enough heat in the job to do it properly. So we'll get some solder onto the iron. I'll just try and get one of the pins to actually attach. So we'll try this one in the corner. Yeah. I've obviously got it bent, let's just straighten it up. I usually do this with magnification, but I'm not doing it so you guys can see it better. Let's see if I've actually got it. Yeah, it's obviously pinned down by that one. I can push on the chip a little bit and just make sure it's sitting flat on the board, yeah. So there you see, that's fairly straight. It's a bit too much this way at the moment, so we can just get hold of it, warm the one pin and slide this into position. Again, just a little bit more. And we basically just need to get it straight. Okay, so that's it. It's now nice and straight. You can see it's nice and flat. And we can now come and solder the other pins. I would normally go for the one on the opposite corner to the one I've just tagged. So which is just down here. A little bit of solder. Probably a little bit of flux now would be a good idea. So just get a little bit of fresh flux on it. Okay. Yeah, just a bit. Don't need too much. We can get this corner. And now our chip is soldered down. Yeah, it's soldered down. We can come back to the first one again. It often helps just turn the board into an orientation that suits you to work. You can get this one again. And now I can go down all of them. And you'll see, with this chunky soldering iron, I have absolutely no problem soldering this little surface mount IC. I mean, these things are not tiny. You can just roll them again. If you get a solder bridge, which I probably did on the middle there, just clean the bit and come back at it again, and you'll get rid of it. If not, a little bit of braid, but that looks nice and clean, yeah. Turn around this way. Getting in here is going to be a little bit more fiddly, but I'm sure I can do it. So I'll work towards this end. Again, just a little bit of solder, a little bit of solder, a little bit of solder, yeah. Just to be sure, we can look under the microscope, but I'm pretty sure that's soldered nicely. Okay, there's our chip. Looks good. A little bit more flux, cleaner. Isopropyl alcohol. Just get rid of that. And that looks pretty good to me, to be quite honest. And there we have it. If you have trouble soldering things like this in the past and you're using a fine tip or a conical tip, try what I've showed you. Get a good chunky, if it's a T12, get a BC3, which is what I'm using, but there are chunky tips we can use on other soldering irons. Let's just turn this round and look at it from another angle. There we go. So it's actually nice and clean. You can see in between. Yeah, that looks very clean there. That looks very clean. So there's no solder bridges. So as I say, just find a good chunky tip for your soldering iron and then see how it goes then. See if you can do it better. Worked for me. Okay, it's plugged in. So we press the button, the light comes on and stays on. That's a good sign. Do I have anything on the screen now? I mean, bear in mind there's no hard drive video, but you would expect to get the BIOS screen, and so far I don't. In fact, the light's gone off again, it's come back on again, but it's not blinking like it was before. Let's see what happens. And I would have to say it still isn't working. Okay. Let's see if the fan's spinning. The fan's not spinning. Let's have a look to see if we have any voltages on it now, and we can also try an external monitor as well. So power light is, yeah, it's on, and the fan is spinning, and the fan stops spinning again. Okay, and it's working. It's actually on now. So it just took a few times to boot up, and it has booted up. So guys, those of you who said it was the corrupted BIOS, you were right, it was a corrupted BIOS in this instance. That's quite impressive, well done guys. Let's just check out of interest the voltage on this one. I'm interested to see what it actually is. I'll just use the flip because it's what I grabbed. Let's have a look. Just for future reference really. Well, interestingly enough, it still doesn't have a voltage supply, but we do have a picture. I'll double check to see if we still have a picture. Yeah, we still have a picture. So that supply, apparently, which is for the GPU, possibly only comes up when the GPU is running. That's interesting. I would have thought it would be there basically all the time if the laptop was on. Again, we can just go to ground, we can just check it. And there's nothing on it, okay? And the core voltage is there. That's another one fixed. Hope you enjoyed this video in 2 parts. It did turn out to be a well-known fault, but I didn't actually know it. I would have had to Google it myself to find it. So let me know if you enjoyed this type of thing, which is a bit more interactive. And if so, I will do it again, but I will try and find something that actually has, shall we say, a proper fault on it next time, yeah? Anyway, I hope you enjoyed it all the same, and I will see you all soon on another Learn Electronics Repair video. Ciao for now, guys.